data shown below displays exponential behavior or not. So what do we know? What can you tell just by looking off of it? Like just looking at it without knowing what they're talking about, what can you tell by looking at this table?
There's a chart.
There's two different sequences. What can you tell about the top sequence? It's arithmetic. What do you mean by arithmetic?
We both add them, keep adding 5.
You're adding a constant at the top. Okay, so that's good that you see that. So you add 5 in order to get the next number. Perfect. What do you notice about the bottom one?
It divides by 2. Just like
You divide by 2, or you
Subtract.
multiply by
1/2.
1/2.
What if you go backwards? You can do multiply by 2.
But do we ever work from that way?
No, we do not, Miss Lee.
No, we do not, Derek. So to get from 0 to 5, we added 5. To get from 5 to 10, we added 5. From 10 to 15, we added 5, so on. From 64 to 32, in order to get from 64 to 32, you had to multiply by 1/2 or divide by 2. But we know when we're talking about the geometric sequences, we don't say that we're dividing. We always figure out what we're multiplying by. Okay? Say
How
what?
do you multiply 1/2 and then get 32? Like,
Because basically,
Half of 30, or half of 64 is what?
32. 32.
There you go.
Also,
Okay?
So you might as well put 1/2.
So whenever you're trying to determine whether or not it displays exponential behavior, think about the zombies that we did the other day.
that was fun.
Okay? What did we find out about when we were adding 1 every time? What do we say that was?
arithmetic,
An arithmetic sequence. An arithmetic sequence, what did we say about it whenever, what type of function it was? Do you remember on the back of the sheet, what type of function did we say it was? It was a linear function. Okay? Well, what did we say about with the zombies? Now that everybody was allowed to eat zombies,
Exponential.
it was exponential, and that was a geometric sequence.
Okay, we
Okay.
were multiplying.
So the first thing that you have to look at is you need to look at your x at the top, and even though you said it's an arithmetic sequence, you might be thinking in your head, okay, bam, it's linear, but that's not true. You always have to look at the top and see if it is being added by a constant rate. That's what you want. You want to be adding by a constant every time. Then you look at your y, and the y is what determines if it's exponential or if it's not. So if you're adding by a constant on the bottom, that wouldn't be exponential. But because we're multiplying by something on the bottom at a constant rate, and the top we added by a constant rate, that means that it is exponential. So this is a geometric sequence. I can't spell. Those 3 dots means therefore.
Wait, 3 dots means 4.
Therefore.
Oh,